Microservices are an increasingly popular software architecture style that structures applications as a collection of highly maintainable, loosely coupled, and independent services, each typically owned by a small team. If you are wondering if you can use the .NET platform to build microservices, or if you have perhaps been asked to start building them in your company, it is worth checking out the multiple existing and new features that .NET 5 offers today and that you can use to your advantage as you drive towards building resilient microservices with a minimal amount of code. So let's get started. In this video, you will learn how to create a .NET 5 microservice from scratch, how to build and debug a .NET 5 project in Visual Studio Code, how to interact with your microservice endpoints via Open API and Postman, how to keep configuration and secrets separate from your service code, how to simplify your HTTP requests to external endpoints, how to deal with transient errors on external services, how to report the health of the service and its dependencies, and how to produce logs suited for a microservice environment. To follow this video step by step, you will need a few things. First, the .NET SDK, which includes all the tools required to build your .NET 5 apps. Visual Studio Code, which we will use as our code editor, so to edit, build, and debug our service. Postman, which is a very handy tool to interact with the service endpoints. And finally, some basic understanding of the C# language. To get started, we are going to use the .NET CLI, or command line interface. For this, I will be using the Windows terminal, but feel free to use a simple command prompt, a PowerShell window, or whichever terminal you are mostly comfortable with. And then being in the terminal, what we can do to create our microservice project is actually use the Web API template. So to do that, let's do .NET new Web API -o hello .NET 5. That's going to be our output directory. And then I'm also going to specify the no HTTPS flag. Now, the reason to disable HTTPS with this flag is to keep things simple, and also because in a microservice architecture, SSL is a concern usually delegated to infrastructure components like an API gateway, so that the microservice can safely avoid dealing with it. However, feel free to skip the no HTTPS flag if you rather use HTTPS from the start. So I'm going to hit enter here, and that's going to generate our files for our project. So I'm going to just switch there. And now I'm going to be switching to Visual Studio Code. To do that, I'll just type code dot. And here we are in the Visual Studio Code interface. Now, the first thing the Visual Studio Code usually do as soon as you start one of these .NET projects is to offer you to add a few files. And we're going to say yes, and we're going to explore what those files are about. This file here describes how Visual Studio Code is going to run a series of tasks for us for whichever task we need to execute here. And the main one is going to be the build task. So this says here, okay, so we are going to have a task called build that's going to run the .NET command, which is a process. And the arguments for that command are, so it's build because it's .NET build. And then here's the project that you had to build. And then here's a couple of other properties that you want to pass to the build engine. The other thing that I wanted to mention is launch.json. So this is the file that describes really how we're going to launch this project from the Visual Studio Code perspective. And what this describes is that the pre-launch task for launch is build, which is the one that we just saw here. You see, we said build. So we have to, anytime you're going to launch this project, you first have to build it. And then you're going to be running the program that's up over here. So this is the location where our DLL will be generated. And also when the host is ready, when it says, yeah, I'm ready to go, it is supposed to open a browser so that it browses to the location of the host. This is where we describe the ASP.NET Core environment where we are in right now. So this is why it knows that we are in development environment and not in production. So now that we have done that, what we can try doing is first let's build this project. And you can do that by going to terminal, run build task, build. So this opens the integrated terminal in Visual Studio Code. and boom, it has been built. And now that it's built, we can go ahead and run it. So to run it, I'm going to click here. I'm going to say start debugging in this debug hub. To see it better, perhaps I can expand it a bit. Yeah, then the core launch. So just run this. It's going to build it. And now we're opening the browser, and here we are. Now the default URL that we have configured right now is not pointing anywhere. So if you want to actually see something, what you can try is just going to the Swagger URL, and this is going to take you to this, the Swagger UI or the Open API specification that we talked about before. So here is where you can start testing your API. So if you click, let's say on get, is the only thing that we have defined so far. So get for weather forecast. Here you can see a description of this API, and you can actually try it out. So you click here, and you just hit execute. You're going to see that Swagger UI generates the command that will be needed. Here's the request URL, and here's the output that we got. As you can see, it's just simulated objects based on what we have right now in the controller. Now, one thing, one kind of a tip that I have in this case, I'm just going to close this, is how do we build this more quicker for future iterations? Like one thing to consider is that you can just do Ctrl+Shift+B to open this this build task window here, right? So that speeds up things a bit. But to really make it even easier, what you can do is let's go back to task.json. Here you can add just a little segment here, just 3 lines, I think, which is the group. So this grouping field here allows us to specify that this is going to be the default task. So build becomes the default task when you do the you run the build task from the terminal menu. So if you say now terminal and run build task, it will go ahead and just build. It will not pop up the build window anymore. And if you do Ctrl+Shift+P, the same thing, it will just go ahead and build. Okay, now you notice that when we started the project, it did not just go to the Swagger page. It actually had trouble getting there. And that is why we're missing a little bit of configuration here in sorry, not in launch settings, launch.json. So here I'm going to close this. And so in order to tell Visual Studio Code where you want to start when you launch, you just have to add this URI format section here in server ready action, where we're saying that wherever the host and port it is, just append /swagger to the URL, and that will be good enough. So again, we go to the debug hub, and you click here. You can also just type F5, by the way, and will be the same thing. So now we run, open the browser, and we are right there in the Swagger UI. So now this is nice to try out the APIs, but eventually I find that there's other tooling that can become pretty much more handy to test the APIs. And this is because you may not want to be opening a browser every single time that you just change the code in your app. So to do that, let's open up the Postman program. So here we are in Postman, and like I said, Postman is a tool that you can use to query any API that you have available really anywhere. So what I'm going to do is just go back to the browser, and let's remember which was that URL. I'll just hit execute again. Here it is. This is the request URL. So I'm just going to take that, and I'm going to create a new request in Postman, a get request. I'll just put my URL, and I'll hit send. And as you can see, we have the response right here. So the nice thing about Postman is that we will be able to start creating a bunch of requests here without having to worry about opening browsers to test the APIs. And if we're going to do that, let me actually just stop this. What we may want to do is just to actually prevent opening browsers all the time. So I'm just going to be, I'll just remove this from here. So no more browsers open from VS Code. I'll hit F5 The only thing that I'm going to get is this prompt here that says, so yeah, we are listening in that port. But then I can just switch to Postman, hit send, and now we get my results. So I will not be dealing with browsers anymore, since I'm working on a microservice web API kind anyways. So to make things a bit more interesting, and since we're trying to create a microservice and want to showcase a few of the nice things that we have available now with .NET 5, what I thought we could do is just bring this project a little bit more into reality. So what if we can just change this project and make it actually query some weather information, perhaps from some external service, so that we can actually tell the weather of some city, right? So to do that, what we can do is just take advantage of a service called Open Weather. So I'm going to go to this page now. It's called Open Weather Map.org. And here, sure, let's allow location. This service allows you to query a bunch of APIs. Several of them that are free that you can just query weather data. So for instance, if we go to this API here, you can see that you can use this to query the weather for some city, and as long as you have an API key available. So the API key is the way that the service identifies you. So the first thing that we're going to need here is to actually get an API key. So to do that, I'm going to hit there. Here is where you're going to need to create an account. It's totally free. And I already created mine. So I'm going to go to my account. All right. There it is. And you will get, I think you will get one key by default. This is what I found the first time that I came here, but you can create as many API keys as you need. So I'm going to copy my API key. Actually, not copied yet. Let's look back at the API over here. So let's actually test out this API. Since we have Postman available, how would this API look like? So I'm going to go back to our page. I'm just going to close Swagger. I'm actually also going to stop this code, and I'm going to go back to Postman. So I'm going to open another tab here, and I'm just going to paste what we just found. And then I'm going to put HTTPS here. This is an HTTPS API. And we want to query data for some city. One of the closest cities to me, a very nice city is Seattle. So let's do Seattle. And here's where you will paste that API key. So I'm going to go back to the Open Weather page. I'm going to copy this API key. And I'm going to paste it right here. And then I'm going to be hitting send. And here it is. We have some information about the weather of Seattle as of right now. And really the most meaningful pieces here are this kind of a description of the weather. Not surprisingly, it's raining in Seattle. Then we have the temperature. And this temperature is actually in a bit of a different measurement than what you would expect. So what we're going to do is just change this a little bit so that we can append units equals metric. So that's going to give us the weather in Celsius. Let me hit send. Let's see. Yep, that makes sense. It's pretty cold right now around here. And we're choosing Celsius just because to play around with that with these objects that are already being generated for weather in that project, right? And the last one that we're going to pay attention here is the DT, which represents the current time, or the time of the calculation of this weather information. Okay, so now that we have this, how do we integrate? How do we call this API from our microservice? So to do that, let's go back to the project. The first thing that we're going to need is to actually specify, there are two interesting pieces from that API, which are the endpoint, the location of this API that we need to call. And the other interesting piece is going to be the API key. So this we are going to treat as configuration, as you should do in any microservice. You should not just hard code these pieces of data. you want to set it in such a way that you could change them anyway without having to really touch the application. So how can we bring that in? Let's go back to the project. I'm actually going to close all this stuff. And what we're going to do is we're going to create a class that's going to represent that information in the project. So to do that, I'm just going to say new file, and we're going to call this service settings. So let's put it in the same namespace as everything else, which would be hello.net 5, and let's do our class, which is named service settings. And here we're going to add a couple of properties, right? The first property is going to be, let's call it open weather host. And let's add a second one called API key. Okay, so we have these two properties. Now, and yeah, so this is going to represent the host, just API openweathermap.org, and the other one is going to represent the key. Now, how do we, let's look first at the host. So open weather host. So this is something that we should be able to safely configure for our application outside of the actual code. So that's where we can actually take advantage of app settings JSON. So what I'm going to do is just add one section here. We should have, ideally should have the same name of this service settings class. So I'm just going to copy this. So we're going to call it service settings. Okay. And here we are going to have those same two well, actually just open weather host. We don't want to put an API key here. And yeah, you could, but we don't want to store secrets over here. That's kind of a bad practice. So the host is going to be, like we said, API openweathermap.org. And that's going to be our configuration for the host. Now, what do we do about the key? So we don't want to just type it here. So you should never ever type or hard code or even worse, checking secrets into your Git repository. So to avoid that, what we can do is take advantage of this thing called the .NET Secret Manager. So this is a tool that you can use to safely store secrets in just for your development purposes, not for anything out of your box. And we'll just keep the secrets completely outside of the project, but still be available for your app when you run it. So in order to do that, let me actually open the terminal. So open the terminal here. This is a PowerShell terminal. And what I'm going to do is first, what we have to do is do .NET user secrets init. So this initializes secrets for this project. And if you actually go back to the project, you're going to see that we have user secrets ID. This was just added, represents the identifier of the secrets of this project. Now that we have that, what we can do is .NET user secrets set, and here we have to name the secret that we want. We give the name and a value. The name should be in such a way that it matches the class that we've been preparing for this. In this case, we created this class called service settings, so we'll name it service settings. We'll do a colon, and then we'll do API key. So this is a way to set a configuration based on a convention that .NET knows about. So for this hierarchy where we have service settings and API key, we can totally configure set a configuration named as service settings : API key. And if we had even more nesting here, like if the API key was a compound property and it has even more properties, you could just keep adding columns here for to keep nesting these secrets. Now that's the key, and then let's get the value for that. So let's get that from Postman. In this case, yep, that should be our API key. Here, hit enter, and now the secret has been stored in the secret store, right? So it has nothing to do with the project at this point. It's just stored somewhere in the box. I'm going to close this terminal here. So now what we want to do is to tell our app how to register these secrets into it. And for that, we're going to do well, exactly that. So we're going to register that configuration. That you can do by, again, using the services collection in startup configure services. So you can say services configure. And here you are going to specify the type that we created, service settings. And then just to keep this thing simple, we're going to say, okay, so now from the configuration object, this is the configuration property that we have right here. From that object, get the section named just the same as the class. So the class is service settings. Just find a section that's named as service settings, which happens to be the section that we declare here, service settings. That's why it's good to keep the same name. So just by doing this, we have, I mean, as soon as the app loads, the configuration engine, it's going to find configurations both in app settings JSON and in the secret store that are going to be populated into an instance of service settings that's going to be registered here in the dependency injection engine of .NET 5. So by doing this, we are going to be able to access this configuration anywhere we need it in the application, which is pretty neat. Now, where do we actually write the code to access the API? So to do that, what we can do is create what we call a client, a service client. This is something supported by the iHTTP client factory object or set of objects in .NET 5. And what we're going to do is just create a brand new file here. We're going to call weather client. Same namespace. And then we're going to create the class weather client. Now here in weather client, we're going to need a couple of things. And at this point, I'm actually going to start copy pasting a bit of more code to avoid so much typing here. Two things, an HTTP client object and the service settings object. And I'm actually going to bring namespaces here. HTTP client is the object, kind of the key object that you would use in any .NET app to access external endpoints, right? Like the one that we need to call right now. So we are going to need those two properties. Also, yeah, like I said, a settings instance where we're going to retrieve this settings information. Now what we're going to add is a constructor. In this case, yeah, weather client. And again, here we are doing dependency injection, right? So we are injecting an instance of HTTP client that's going to come, somehow it's going to be constructed in startup, and it's going to be available for us over here without us having to worry about how to build it. And also this iOptions object, which is how you are able to receive the configuration that has been registered right here. So we configure service settings. Now we receive an iOptions instance here of type service settings, which, by the way, I'm going to add the namespace. And then we just grab both of them into our properties, HTTP client. Options has a property called value, and value is the one that actually has the service settings that we care about. Next thing to do is to have some sort of representation or type representation of that API that we saw before. So I'm going back to Postman here, and here we can see, that if we wanted to get those elements that we talked about, we would, at least before .NET 5, we will need to create a bunch of types, since you see there's quite a bit of composition here. So it's not just a flat object. So we need some weather object here, which will have description and the description that we are inserted in. We will need this main class with the temperature, and then we would need just a property or a field for the time. So yeah, before .NET 5, you will need to create at least a couple of classes or 2 or 3 classes for all this stuff. But luckily, in .NET 5, there's this new thing called record types. So record types is a new way for you to declare this kind of objects in a kind of an immutable way, and with a nice addition of how you can compare these objects, not by reference, but by value. But it also has a very nice syntax that can simplify a bunch of scenarios. Like in this case, instead of having to create a bunch of classes, here's what we can do. So first, we know that we need a weather class. So let's see. We need a weather object, right, where we need to have a description inside it. So what we can do is just say, all right, so I'm going to declare a record, the record type. We're going to name weather, and that weather is going to have a description, and that's it. That represents that entire weather object, or that weather section that we have here. Okay, and which, by the way, is an array, is not just one object, but we will need instances of weather. Next one is main. So from main, we will need a property named temp. So to do that, let's go back here, and just like we did with weather, let's declare public record main. So like we said, we need a temperature. We will use decimal for this, so decimal called temp. And just like that, we now have that main structure right there as a record. And finally, we're going to create our overall a record that has all the properties. So let's just call it forecast, for lack of a better name. And this forecast, just like we saw, needs to have a collection of weather objects, an array of weather objects, the main object, and the time. So let's see, we're going to say, okay, so this is a weather array. We need an instance of main, and let's use long for that daytime. And that's it. So here's the entire representation of the interesting pieces for us from that response of the API. So no need to create a bunch of classes for this anymore. Now, where do we actually do the call? Where do we retrieve that weather information? So to do that, we're going to just introduce a new method. Let's call it, and I'm going to do a bit of copy pasting here. So this is going to be an async method, and I'm going to import a few missing namespaces here. I guess just one namespace. Async method called getCurrentWeatherAsync is going to receive a city. So we provide a city, and it should return one of these forecast objects. And in order to be able to actually do the query, what we're going to say is, so let's see, forecast is going to be, we're going to use the HTTP client object. And interestingly, starting with .NET 5, we now have very handy methods for both retrieving information, retrieving and posting information, but also doing the serialization and deserialization for us in a very nice way. So we just need to do, in this case, get from JSON async, and I'm going to add a missing namespace here, systemnet HTTP async. This is the namespace that has the new additions in .NET 5 for this kind of query. And here's where we would paste the actual URL, right? So I'm going to grab that URL from here. Going to paste it here. Yeah, it's all hard-coded. Now, how do we fix this? So we have to await on this because it's an async call. Okay. Now, next thing we're missing here, of course, is the type. So what are we going to deserialize into? In this case, it is a forecast object, the one that, a forecast record object, record type. And now here, we just have to do a bunch of replacements because we do have that settings object just waiting for us over there. So what we're going to do is do a little bit of string interpolation so that we can introduce whatever should be parameterized here. So it's going to open curly braces here. I'm going to say, so this is service, it is what's the name? Settings, just settings. Settings that open weather host. And then the other piece is here. We don't want to use hardcode the city. We want to use the city parameter. And for the app ID, we want to switch to settings.api key, and then we leave the method units as metric. That's just fine. So with that, we should be able to just retrieve that forecast information, just one line, simplified by the additions into .NET 5. And so after having that forecast object, we can just do return forecast, and that's it. We have a weather client that is able to go ahead and retrieve weather information based on some city. Now, just as with anything else, this weather client needs to be registered into the series of services available in our application. So to do that, we're going to go back to Startup, and in Startup, we are going to go to Configure Services, and we just have to say services.add/HTTP client, and we'll say weather client, and that's it. So that will take care of registering this R class into the services collection, and .NET 5 will know that it needs to inject an HTTP client object into that class so that we can do the actual calls to the other service. Now that we have this, well, it's time to actually touch our controller and to make it a real controller that can actually receive a city and return the weather for that city. So to do that, we're going to do just a few things. First, let's get rid of all these random set of summaries. We're going to need to, again, inject an instance of that weather client. So weather client, here it is. And then let's use a little bit of intelligence here. Create an assigned field client. So that's going to go ahead and just generate, you see, generated a private field for me and assigned it from the client parameter right there. Ah, yeah, one thing we're missing here is the access modifier. So this should be public, so we can actually use it on the other side. And we're missing one more thing. Service settings should be also public. Yes, forgot that. There it is. Okay, so going back to the controller, now we have our client available. And now we're going to change this get method here. So that first thing is that we're going to modify the route. So we're going to add here, where is it? Route attribute. And we're going to say that we're going to receive here. Sorry, let me just copy that one over there. Keep it simple. And we're going to receive a parameter here. It's going to be the city. So now we're modifying it in such a way that we're saying, hey, so the route is not just going to be weather. Now you're expected to provide some city here, like let's say Seattle. Right? That's going to be part of the route, right? So we're just kind of describing how we want our route to look like. And then that city we're going to receive here. Okay. Now we're not going to be returning a list of weather forecasts anymore. It's just one forecast for the current forecast for the city that has been specified. And now, yeah, we can remove all this stuff. And what we can do is say, so forecast, bar forecast, say equals, actually we have to turn this into an async method because we're going to be calling another async method. So this is an async task of weather forecast. So we have to say await, and then we have our client. So we'll say client dot get current weather async, and we'll give the city. That should give us the forecast. And then finally, what we have to do is to turn this forecast object that we got here, which is really a record object, into the weather forecast DTO that the app is already using. So to do that, let's just do return new weather forecast, and then we'll do so the summary is going to be forecast dot weathers. Let's take a closer look at this. So says weather's here, but it's really just one weather object. So I'm just going to rename to weather. That's how it shows here. Even if it's an array, it's just named weather. So we have to honor that. So I'm going to say weather there. Of that collection, we want index 0. And from that one, we just want description. Next one is the temperature in centigrades. It's going to be forecast main temp. Also, we have to convert this into an int to match into that contract that we have. And finally, the date. That date is actually in a kind of a Unix-based time set. So what we're going to do is date time of set from Unix time seconds. Forecast t dot datetime. Datetime, yeah, that should do it. Yep. So let's see, are we missing something? Yeah. That's so. Let's try to build this. It builds. I'm going to do F5 here to run it. And so it starts. So now let's go back to Postman. And so we're going back to our API. It is not anymore just weather forecast. We have to specify the city, right? So let's do the Seattle sample here. See what happens. Boom. Here it is. Yeah, still very cold in Seattle. So, but yeah, I mean, we got it. I mean, we go ahead as soon as, and in fact, we can explore that a little bit of a breakpoint to make it more interesting. I'll put a breakpoint right here. And so we keep going through this method. So let's see, run to cursor. Yeah, come here. We got the weather object. And let's put a breakpoint back in the controller over here. I'll just do F5. So we come back here, we have the weather forecast object, and then we just do the transformation and we return that weather forecast object over here. And so that worked. That's great. Now, one of the things about microservices is that we want to make sure that they are reliable. So as reliable as they can all the time. And by introducing this external dependency, this open weather service, now we have kind of a point of failure. So what happens if that service goes down? So what does that mean for our service? Can we keep up our availability there? So let's see actually what happens. And what am I going to do here? It's pretty much the only way that I know to test this scenario is to just disable my Ethernet temporarily. And I'm going to hit send again. See what happens. Yeah, after I have a breakpoint, I'm going to remove these breakpoints now. Hit run. And boom, no such host is known. So yeah, we can't talk to it. There's no internet. So now our service is down. So this is exactly what we don't want to happen ever to our microservices. So one way to start dealing with this, one first approach that we can do is, well, let's do some retries, because it potentially can be a transient issue which happens all the time in the cloud. So how can we introduce some retries to this? So let's go back. First, I'm going to enable actually the Ethernet because we'll need it for the next step. And I'm going to go back to our app. So I'm going to stop it. So what I'm going to do now is I'm actually just going to close all this stuff, go back to the project, and actually going to go to open the terminal, and I'm going to add a new NuGet package. So to add a NuGet package to your project, you have to say .NET add package, and in this case it's called Microsoft Extensions HTTP Poly. So Poly is a pretty popular package. It's been around for a while, and it allows you to do a bunch of transient error policies where you can specify how you want these errors to be handled. And to do that, what we're going to do is go back to startup. So we don't have to actually modify the entire project to do retries here and there. I mean, like you could think that you may need to go to weather client and do some sort of retry here. What if this guy fails? So try catch and stuff like that. But actually, we can keep things simpler than that. What we're going to do is this. So let's see. Just copy pasting again. Yeah. So add transient HTTP error policy. We are appending this to our add HTTP client class. This is a facility of the what was the name? The HTTP client builder, where we can introduce a policy. So I'm going to actually fix this using poly. So we have the right namespaces. Yes. So this is a transient error policy where we are saying that the policy is a wait and retry policy. It's going to retry 10 times. So that's the policy. Let's retry 10 times. And let's see, on each retry attempt, it is going to sleep as much as what this expression specifies. Now, this is what we call exponential backoff in this case. It means that the first time it is going to sleep for 2 raised to retry attempt seconds. So retry attempt is going to be 1. The first time is just 1. So 2 raised at a 1. So if that after that retry we fail again, I mean after that sleep we fail again, then we're going to wait 2 raised at 2. Right, and then 2 raised at 3, 2 raised at 4. So it's exponential. So each time we wait a little bit more. And this is just to add a little bit of, changing behavior to those retries, to just not keep retrying at the very same interval every single time, potentially overwhelming the service that is on the other side. So let's give it a shot. So this should allow us to do some retries. So what I'm going to do is, again, disable network. And run this, F5. So back here, I'm going to hit send. Just waiting there. It's not just failing now. And as you can see, if I can expand this, we're trying. So we're doing a get. We did already 2 gets here. Get, and there will probably come more gets. You see, get. It just keeps trying. Just expands the sleep. The sleep seconds a bit more and a bit more. And if I just fix my network connection now, so I'll enable this. Yeah, it may take a little bit, but eventually we should get a successful. I think it already did it. Let's go back to Postman. So yeah, there it is, success. So without having to touch really anything other than that little piece in startup over here, now we have retries for our microservice, which is pretty neat. Now, the other thing to consider is that, so that's nice, but what if the service is really going to be down for a while and we don't know? And we don't want to be really overwhelming that other service and just having our clients wait forever in there. So for that, there's this other technique called the circuit breaker that I want to show you here. So I'm going to stop this. And the circuit breaker is going to allow us to introduce a behavior so that we will only retry so many times, after which we do something that we call the open the circuit, and then no more tries are going to keep happening until some other condition happens. So in this case, let me just add this. Let's see, so just appending to the same sentence. So one more transient HTTP error policy called circuit breaker. So this means that we will allow it to retry 3 times. So we will retry 3 times. If after 3 times we keep failing, we just can't get a successful result, then we're going to just open the circuit, and then no more requests are going out. So it will just fail right away. Right, so that way we avoid overwhelming the other servant, and we return fast to our clients, which in this case is much better than just keep them waiting forever. And then that circuit is going to stay open for, in this case, 15 seconds. Let's actually reduce it a bit, 10 seconds. And then after those 10 seconds, it will try again, see if it succeeds. If it doesn't, it just opens again. It just keeps open, and then we enter into that cycle again. So let's see how that works. So I'm going to, again, disable the Ethernet, run this. Okay, So go to Postman, hit send. Let's see what happens behind the scenes. So it is trying. Try it a couple of times, or perhaps already 3 times. So give it a moment. And then, yeah, if I go back to Postman, here it is. Circuit is now open and it's not allowing any more calls. So no such host as known. If I try again, let's see what happens. So yeah, circuit open. And then now we're getting fairly fast results here, as you can see. It's not really waiting. So the circuit is open. It will be open for about 15 seconds. It notices that it tried again. It didn't succeed, so it just stays open. So now let's fix that Ethernet. Enable that. And then, yeah, again, it could take a while, but eventually this circuit is going to, yeah, there it is. Circuit closed. I mean, it tried again and notice that it succeeded. Close circuit, and then we're back into good shape. So pretty handy and pretty common approach when you have to deal with external dependencies in your microservice. Now, so this is good, but is there a way where we can be a bit more proactive with this? So do we actually need to wait for our clients to be hitting these situations and causing unreliability to them? So can we actually detect this situation before it happens? So it turns to be that, yeah, there's a way, and there's this thing, for this is this thing that we call health checks. So a health check is a way for your app to have an endpoint where anybody else from the outside can query for the health of the service. Typically, this would be your orchestrator system, right? Let's say Kubernetes. That system will be pinging this health endpoint to check how we're doing. Let's see how we can enable a health check for this app here. So going back to configure services, it is as simple as doing this. Add health checks. So that registers the health checks types into our app. And now we also have to update our middlewares here. We have to, in use endpoints, we have to map health checks, right? So this adds the routes for checking health. So let's do, you can name this anyway. I'm just choosing health. It's a pretty common name. Some people would do health C, or you could do HC, whichever works best for you. And that's it, really. Hit F5 again. So let's go back to Postman. And now what we want to do is to actually, I'll just grab the base host. So I'm opening another tab here, another GET request. Now I'm going to do health. Hit send, healthy. So this means, okay, so service is saying, yeah, we're all good. Now what happens if I disable the Ethernet? So disabled. Let's try again, send. And interestingly, we keep getting healthy. So this is a good point, because even when our service is up and running, which is great, the dependencies of the service, in this case, the external service is down. So this is exactly one of these things that we want to detect via health check, right? So to do that, what we're going to do is, let's go back to the project. Let's stop this. And what we can do is create what we call a health check. It's just a class that implements a health check, where we can do these additional checks. So let's add that. So let's call it external endpoint health check. All right, so I'm going to grab that name. And then let's add our namespace. Hello.net 5. And then let's do a class. Let's make it public. Yeah, the external endpoint health check. This class has to implement a health check. .NET 5 type. And as per doing that, it has, let's actually implement the interface right there. And what we're going to need, since what we need to do is verify, I mean, the way that we can verify this is just by doing a very simple ping, right, into that open weather endpoint. So for that, we're going to need those service settings again. So we're going to need to inject those into our constructor. So let's add a constructor for this class actually. And just like we did before, we use the iOptions pattern to receive those options into injected into this class. And we are going to add a property here too. We can actually just generate that. So let me do this. We'll say create and assign field options. We don't actually want the options, we just want the service settings. So let's do that. Settings. So this dot, yeah. So settings equals options to value. There it is. Okay, and now we have to implement check health async. And so yeah, for that, again, I'm just going to grab a little bit of implementation from here, and let's see what this means. So I do have to import a few types. So basically, ping is available in system network information. And here I wanted to show you one new thing in .NET 5, which is this way of declaring a new type. So usually before .NET 5, you will have to do, well, ping equals new ping. But since this is a bit redundant, because yeah, I mean, why would I be creating if it's not an instance of ping? You can just avoid that stuff and you can say equals new. And that's all it is. You get a new type. So just a bit of simplification. So appreciate it from .NET 5. Now, next thing, let me add, yeah, so this method should be async. Otherwise, how are we going to do an async call? And what we're doing here is very simple. So as you can tell, send ping async, and then we're taking advantage of the OpenWeather host that's available in settings. We ping that, we get a reply. If the reply is not successful, we say, hey, this is unhealthy. Otherwise, it is a healthy result, and then we're going to return a healthy result over there. Yep, so that's our external endpoint health check. And what we have to do now is to actually register that health check with our app. So to do that, we're going to expand this add health checks with, with add check. And in add check, we're going to add external endpoint health check, the class that we just created. We need to give it a name. So we'll name it just as, like, the right name will probably be OpenWeather. You can use any name here. And you can imagine that as you introduce more dependencies, you will just keep adding checks here, right? So for your database, for your service broker, for I don't know, any other service that you may need to query outside of your own, right? In our case, it's just OpenWeather for now. It's good enough. And just by doing that, we have health checks. Let's see, F5 again. So back to Postman, and I think we don't have network right now. Yeah, we don't have it. So let's check health, send, and boom, unhealthy. Because the health check is telling us now. If we enable Ethernet again, we should get hopefully healthy. Healthy it is. Yep. So like I said, so this endpoint will become key to whichever monitor or orchestrator system is trying to make sure that your service is up and running, so that we can detect that situation, fire some alert, and do something about it before our customers start hitting our microservice and hitting this problem. Now, one last thing that I wanted to show you that's fairly kind of useful in terms of microservices, and that's enabled by .NET 5, is the way that we present logging, right? So let's see. So usually, let me actually stop and start this again. Normally, the way that you see the logs are like this, right? So this is kind of a structured logging. That's what we call structured logging. So each of these lines is kind of an object that represents the level of the log, who is emitting that log, and then what the actual log is, right? So that's what it shows there. But in a microservice architecture, is not very uncommon to want to, I mean, the recommendation is that you just log everything into your console. A typical approach is log into the console, and there will be some infrastructure pieces in your deployed environment that are going to take the logs from that console output, and are going to be probably transformed and then eventually sent to some logging backend, right? So there's a bit of decoupling between you producing the logs and those logs being collected in some other backend, right? It's very different than like more of a legacy or monolithic systems where you would just log to some file or to some location. It's really not like that. You just log to the output and then somehow that output is being transformed into logs eventually. However, to make that happen, this kind of structured logging that we're seeing here is not really useful, right? For machine, it's not machine readable really. It's human friendly, but not machine readable. So what we really want to have here is JSON output. How can we get JSON output here? So it's actually very straightforward with a new edition of .NET 5. And what we're going to do is just close this and go back to program CS. And here we're going to expand the way that we configure the host. So we're going to say, hey, let's also configure logging. As we are configure logging, we're going to receive a couple of parameters, context and logging. And we're going to get a Lambda expression here where we can do stuff, right? So here we're going to, one thing we can do is just say, hey, so we're going to do login.addJSON console. The JSON console is a new console available alongside all the other login providers in .NET, available now in .NET 5. So just by doing this, and we hit F5, you'll see that the logs will now also show up as JSON. So let's see. So this is the structured logging version. I mean the simple console version of the logs. And here is the JSON version of the same log, as you can see, which will be machine readable by the logging infrastructure in a microservice architecture. And so, yeah, that's kind of what we want. However, now it has become actually a bit super noisy for us, so we can't really tell much of what's going on here. So one thing that I like to do is to just have a bit of a variation here. So depending on the development, depending on the environment, either use the simple logging or use the JSON log for this. So one thing that you can do is, since we have the hosting environment is actually available in this context object here, what you can do is something like this. Let me actually just do a little bit of copy pasting again here. There. So here we're saying, hey, so only if the hosting environment is production, go ahead and remove the simple console and then add the JSON console, and that's it. So now if we run again, we're just back into the simple console because we are in development environment. But if we were in production, this would have turned into JSON. So I hope this was useful. And if you have any questions or if there's something else that you would like to see in this channel, please leave me a note below. Consider hitting the like button if you're getting any value out of this. And don't forget to subscribe if you'd like to know right away when I publish any new videos. Thanks for watching and see you next time.